Welcome to Special Parallelograms. Today we're going to talk about all kinds of shapes that are also parallelograms, but we're going to be more specific. So there's going to be three more shapes that we need to talk about some properties on. These are the three shapes that are also parallelograms. Right now these are the definitions, only the definitions, not the properties. So first thing we know, a rhombus. It's a parallelogram first that has four congruent sides. I know when we say four congruent sides, a lot of people think it's a square, but it starts as a rhombus. So we only know all four sides are congruent. A rectangle, the definition of it is a parallelogram first, and then it has four right angles. So we know, of course, all the right angles are in the corners. So there's your rectangle. Then the last one we have is a square. Four congruent sides and four right angles. So a square is not only a parallelogram, but it is also a rhombus and a rectangle. So we put both of those together, and that gives me a square. First property of a rhombus. In a rhombus, diagonals are perpendicular. So we see the right angle in the middle there that's formed. So what that helps me with is that all of the triangles in a rhombus are right triangles. Because starting in this section, we're going to be looking at all of these as triangles. So I also want you to add, we have right triangles when we have a rhombus. One other property we know in a rhombus, diagonals bisect opposite angles. So what that tells me is this angle is the same as this one, which is the same as this one, which is the same as that one. So the little angles across from each other are now congruent in a rhombus. So which also means that one and that one and that one and that one are also the same, but only in a rhombus. Does not happen in a parallelogram. So the little angles across from each other are not going to be congruent in a rhombus. Now moving on to a rectangle. Here we have a rectangle. In a rectangle, diagonals are congruent. So I want to go into a little bit more. Remember, in a rhombus we said that we have right triangles. Well, if we go back to knowing that this is a parallelogram and diagonals bisect each other in a parallelogram, then I knew this side was the same as that one. Well, if the length of both of these diagonals are the same, that means that length is the same as that one. Now if we look at this, all of these triangles have two sides that are congruent. So that makes it, in a rectangle, we have isosceles triangles. Well, why do I need to know that? Well, there are some special properties we learn about isosceles triangles. Remember, in isosceles triangles that your base angles are congruent. So that tells me that this angle down here is the same as that one, which would be the same as these two up here. Then also, this angle is the same as this one, which would be the same as the two over here. So please don't get a rectangle mixed up with a rhombus. In a rhombus, we had all the little angles across from each other were congruent. In a rectangle, we had the base angles are congruent in each of the triangles because they are isosceles triangles. Last thing we want to talk about is a square. So in a square, all theorems or properties that we just learned apply to a square. So since a rhombus was a right triangle and a rectangle was an isosceles triangle, that means in a square we have an isosceles right triangle. So, well, how does that help me? When I have an isosceles right triangle, that means your base angles, here's your right angle here, your base angles here are congruent. Well, we know those two acute angles have to equal 90. Well, if they're both the same, they equal 90. That means each of these little angles around here are always going to be 45 degrees. Every single one of these angles going around in a square, keep in mind, only in a square, are always going to be 45 degrees. So that's going to be very helpful that in any size square, those angles are 45 and all the angles in the middle are always right angles. So that's very helpful in a square. Now we want to take a look at a few examples here. We want to classify this quadrilateral. So we have to look at what's marked. Now these are supposed to be marking that my angles here are congruent. So I see those angles are congruent and these angles are congruent. So that tells me opposite angles are congruent, which makes it a parallelogram. But one thing I have not used yet is that I have these two sides marked congruent. When we think about it in a parallelogram, I know opposite sides are congruent. So if this side is marked with 1 mark, that means this side is also a 1 mark. Same thing with this. The same way this side is marked, I can mark its opposite side because I know they are the same length. Now if I pay attention to every single one of these, that means all 4 sides are congruent. So we got to look back and see, well, which kind of shape had all 4 sides congruent? You're right, I believe that was a rhombus, so this should be a rhombus. That is our more specific name for this shape. So don't call it a parallelogram, it is a rhombus because all 4 sides are congruent. So next one I'm going to look at is some angle measures. We're going to find the given measurement of the measurements in rhombus LM in P. Being that I see that I have angle measurements, I have to think, well, what kind of triangles did I have in a rhombus? So if you go back in your notes, you need to look and see that I had right triangles. So my right angles are the angles in the middle here. I also know, if I look back at my properties, that all the little bitty angles across from each other are the same measure. So if this one's 30, that means that one's 30, and this one's 30, and that one's 30. So before I even look at the question, looking back at my properties, I can label all of those measurements. So we start with the measure of angle LMQ. So LMQ is here. I do not know that measurement, but I know that one's 90 and that one's 30. So I can do 90 plus 30, which gives me 120, and subtract from 180 since it's a triangle. So that tells me that this angle here is 60 degrees. So LMQ is 60. Next we have LQM. LQM is going to be this angle right there. So you see it's marked a right angle. So that's 90 degrees. Last thing I asked for is side MN. Being that it's a rhombus, I know all 4 sides are congruent, so since this is 5, that means MN also has to be 5.